Chapter 5, How the Markets Work and Demand, is the first chapter in our study of the mechanics of economics. I like to use the word mechanics with regard to the study of economic systems because economic systems are very similar to engines. An engine, as you know, is physical capital, and an engine uses energy to produce things for us, everything from power to articles of clothing. Well, an economic system also uses energy to produce things like goods and services, as well as higher standards of living. Engines have component parts that contribute to their proper functioning, and so too does an economic system. In this chapter, Markets and Demand, we start to take apart our economic engine to study the component parts and how they work together. In this chapter, we're going to look at the fundamental concepts behind two components of our economic system or economic engine. The first is we're going to look at what a market is, and then the types of markets that exist within our system. Then we're going to move on to the second component of our system and the concepts behind it. We're going to define for you what demand is for goods and services in a market. We're going to introduce you to the concept of the law of demand. We're going to illustrate for you how demand can be measured and illustrated through the use of a demand curve. And we're going to take a look at the causes and effects of demand changes within a market. As I mentioned a moment ago, let's start with defining what a market is and take a look at the different types of markets that exist within our economic system. So let's start our brief look at markets by defining what a market is for you. And here's your simple definition. It's any arrangement that allows a buyer and a seller, or buyers and sellers, to exchange things. And here's a very important point about markets. Markets exist because no one entity, meaning a person, a business, or a country, is or should be self-sufficient. This refers back to a lesson that we learned in Chapter 2, in the second part of Chapter 2, when we were introduced to David Ricardo's concept of a comparative advantage. Countries trade, people trade, businesses trade to try to obtain a lower opportunity cost to support themselves. And as a result, markets are created. Now, the definition of a market is pretty broad. So the types that there are a broad range as well. Here are some simple examples. Stock exchanges are markets. The internet is a market. The mall is a retail market. The classified pages of the newspaper and yellow pages are a market, old-fashioned as they might be. If some of you are not familiar with the word classified as it relates to these two items, here's some background for you. A way of grouping based upon shared characteristics to assort or categorize. The classified advertising section of the newspaper had a section for selling used cars. Categorize it. Some other examples. Product and service specific markets such as produce, meaning fruits, vegetables and the like, automobiles, jeans. We consider those separate markets. And we even have geographic markets. Yuma could be considered a market for quite a number of things. The bottom line is that markets exist in all shapes and sizes, trading all types of goods and services. We're going to take a pause in our look at markets at the moment And we'll come back to markets in Chapter 8, at which time we'll look at the characteristics of markets and ways to go about categorizing them. And now we'll move on to the second major component of our economic system that we're looking at in this chapter, and that is the component of demand and the concepts behind it. We like to measure activities in markets, and we do that in a number of different ways. One way we do it is measuring demand. So let me give you the definition of demand, and I think it will start to become clear to you what this measurement looks like. Demand is the potential consumption of a good or service when people are willing and able to buy it at a specified price. Now, a couple things I want to point out about this definition, actually break it into three component parts that are important. With demand, the concept behind it, we're looking at potential consumption. Okay, that's the first thing to understand. Second, for both goods and services, when people are willing and able to buy something, okay, they have to be willing and able, and it has to be at a specified price. Now, I also have a note here that perceived value is subjective, and the potential for somebody to buy something, a good or a service, is based upon perceived value. And what people assign to a good or a service in terms of the value, it is subjective. The old phrase, in the eye of the beholder, if you will. There is a supplemental video on the class website that I highly recommend that students make themselves available to watch on value being subjective. It gives a real great explanation of how that applies in this case. So again, I highly recommend that students take that in. Demand for good or service in a market can change for any number of reasons. Some people would even say thousands of reasons or thousands of things can cause demand, potential buying or consumption to change for a good or service. Yes, there are many things that can change demand for a good or service in a market, but don't panic. We're going to make it easy for you to understand this. And we're going to do that through two ways. The first is that we're going to categorize the things that have an effect on demand. And in fact, we're not only going to categorize them, but we're going to focus on just the most common things that will have an effect on demand for products and service in a market. And the second thing we're going to do in conjunction with the categorizing, we're going to teach you how to use a simple graph to illustrate the effects of demand changes. These two things in combination will help make it easy for you to understand this concept. So let's get started. We're going to look at the 6 most common things or categories that will affect a change in demand for a good or service in a market. And let's take a look at the first one. Price change. And here's what price changes do to affect demand. They will affect the quantity demanded of a product and not the total demand for the product in the market. And what we mean by this is that as a price changes, the quantity of a product or service that's demanded at each price level will change, but it doesn't change generally the total demand or potential that there is in a market. We'll take a look at a graph and we'll start to see how this is illustrated, and it will help to make it easier to understand for you. And here's the graph that we're going to use to help you get familiar with the concept of demand as it relates to markets. It's called the classic supply and demand graph. And in this chapter, we're only going to concentrate on the demand aspect of things in markets. The supply aspects of things we'll get to in due time in Chapter 6 coming up. Now, the classic supply and demand graph is the most commonly used tool in the study of economics. It's used to illustrate a number of conditions and situations with regard to markets, and in many cases, the overall economy. So let's get started here with our simple and first example using this tool. In this example, we're going to set up a hypothetical situation. Let's say we are trying to illustrate the market and aspects of demand related to this market for whiteboard markers in what we'll call Anytown, USA. And Anytown, USA in our illustration here has a population of, let's say, 100 people. Now, this curve on the graph that you see here is our classic demand curve. And what this simply illustrates is that this market, based upon this population, we can expect the following. For example, at a price of 5, we could expect to probably sell 10 boxes or approximately 10 boxes of markers. And at a price of 1, we could expect to sell somewhere between 50 to 60 boxes of markers. Now, there are a few other things about the characteristics of the classic supply and demand graph that I need to cover with you here and make sure you thoroughly understand. Let's take first the characteristics of the graph itself and talk about some of the labeling. For example, the axes. The vertical axis is labeled price with this tool, and the horizontal axis is labeled quantity. In this case, quantity demanded, because we're talking about demand. Now, these labels for the axes are always the same. They never change. Some people want to try to change them at times, but they never change. The vertical is always price, and the horizontal represents quantity. Now let's talk about the characteristics of the demand curve. A demand curve will always slope downward from left to right. Again, always slope downward from left to right. Now, you may see demand curves that have different intensities of slope that are positioned differently on the chart. Some will have what we'll call shallow slopes, others will have very steep slopes. But you'll see that a demand curve will always slope downward from left to right. A couple of other things about characteristics of our chart here. The demand curve on our charts always represent all the possible demand for markers, in this case, and using this example, within a market at each price level given the population of the market. The assumption is also made, and we use a Greek term to label this assumption. It's called ceteris paribus. We use the assumption that all other things that could have an effect on total demand in a market are held equal except for price. So our classic supply and demand graph is really looking at holding off all other potential factors, what we can expect from both demand, which we're looking at here with the demand curve, and later on we add in the supply curve, what can be expected from the market given the price levels illustrated. The next thing I want to talk about is the law of demand, and it's a pretty easy concept to understand. In fact, I'm sure all of you began to pick up on it a moment ago when we looked at the classic supply and demand graph. Here's the definition of the law of demand. When the price of a good is low, consumers will buy more of it. And the reverse is also true. Demand curves illustrate this. They reflect the law, and they help us with predictability about consumption in markets. If you're not familiar with the word predictability, it means to foretell or forecast, state or make known in advance. Used in another sentence, based on prior experience and statistics, he predicted that the team would win. So here we have our demand curve, and as we saw a few moments ago when we looked at this the first time, we saw that it was clearly illustrated that expected at a price of 5, we would sell less markers to the market than at a price of 1, we would sell much more. But I want to make one point from a business perspective here in terms of measuring markets and measuring demand as well. A point of clarity. It's important to note that economists measure consumption, meaning demand, on the amount of goods purchased, not on the amount spent to buy them. So we're measuring units, not dollars. Although we're looking at effects of price, we're not measuring dollars, we're measuring units. Here's another important concept that you need to understand with regard to demand as a component of our economic system and as a measurement of activity in a market. And that concept is what we call elasticity of demand. And before I give you the definition, let me point out something with regard to the word elasticity. If you're familiar with the root word elastic, it means pliable, flexible, or responds to some force or change. Many people substitute, particularly in this case, as we're talking about demand here, they substitute the word sensitivity for elasticity, and that's perfectly fine. So if sensitivity works for you, that's great. So let me give you the definition behind the term here, elasticity of demand, to show you what we're talking about. It's a measurement of how significantly consumers in a market will cut back or increase their demand for a good or service when prices either rise or fall. In other words, how sensitive is a good or service to a price change, either an increase in price or a falling in price. In other words, when we say how sensitive is the product or service, meaning the demand for it. Now, there's a key principle associated with the elasticity of demand, is that the elasticity or sensitivity of demand for a good or service varies at every price level. A price change, for example, in the chart we were looking at before, a price change of some sort at the $4 level, either up or down, maybe have a more significant effect on demand than a price change at a $2 level. The sensitivity or elasticity of demand for a product or service within a market can actually be calculated. Some businesses find this to be a very useful tool to help them in some pricing strategies and also at times inventory management. Here's the formula. It's a very simple one to follow to figure out the elasticity of demand for a product or service. We simply take the percent change in quantity demanded of the product or service and divided by the percent change in price. In a few moments, I'm going to show you a couple of examples about how to figure out elasticity of demand for a couple of products and services. But before I do, I'd like to talk about another way that we use the concept of elasticity. And that way is that we classify demand for goods and services, or in that matter, we actually classify goods and services as to how sensitive they are to price changes. And there are three categories or classifications that we use in this process. Here's the first one. If a product is called elastic, What we mean by that is that demand for the good or service is very sensitive to price changes. And then when you plug in the numbers to figure out the elasticity, if the equation comes out to be greater than 1, you can put the label of that product or service as being elastic or very sensitive to a price change. What you will also find is that the demand curve, in this case with an elastic product or service, will have a fairly shallow curve to it. The second type of classification that we apply to products and services is called unitary elastic. And this is a situation where the demand for a good or service is proportionally equal to the change in price. In this case, if you plug in the figures and the number comes out as your solution to be very close to 1, or actually the number 1, you can label that product as unitary elastic. If you're not familiar with the word proportionally, it means forming a relationship with other parts or quantities, relating to math, having a constant ratio, and that's really what we're talking about here. Used in another sentence, the improvement in business conditions had a proportional effect in the unemployment rate. The third type of classification that you could label a product or service with would be that of being inelastic. And when we say a product or service is inelastic, we're saying that the demand for that good or service is generally not sensitive to price changes. And when you do your math, you'll find that these products will come out to have a solution to the elasticity math formula to be less than 1. And you will also find that their demand curve will have a very, very steep slope to it. Before I move on to one other concept and then to our examples for calculating demand elasticity, let's review what I just talked about in terms of the classification of products and services by their sensitivity to price, and also what their demand curves might look like. And we'll do that through some examples of food for thought here. So here's our first situation. What would a demand curve look like for an inelastic good? Now remember, a moment ago I mentioned that the classification of inelastic means not very sensitive to price changes. And the classic example of an inelastic good in the study of economics is gasoline. Gasoline is so critical to our society and our day-to-day functioning, yes, in a modern society, that we will almost pay virtually any price for our gasoline. Now, notice a couple of things about the curve here. As I mentioned, inelastic products have very steep curves, and as you can see, the difference between the amount of gasoline that's demanded between price level 1 and price level 3, there's not much difference. However, you will notice that at price level 3, demand does fall off just ever so slightly. And here's the reason for that. You have a general set amount of income that's available to you to buy goods and services for your survival. If the price of gasoline rises to a level to where you don't have money to pay for it, but still you need to be able to transport yourself around, you will seek other means of transportation, whether it's walking, taking public transit, or riding a bike. So at some point, at some price level, the demand will fall off as the prices go up for an inelastic product.
Now let's take a look at what a demand curve would look like for an elastic good or product. As you may recall from a few moments ago, an elastic good is one that is highly sensitive to price changes. And the classic examples used to illustrate an elastic good are any type of produce. In this case, we'll use corn as an example. Now, a moment ago also, when we looked at an example of a demand curve for an inelastic good, you saw that the demand curve had a very steep slope to it for the inelastic good. Here we have the exact opposite. For an elastic good, the slope of the curve is what we call very shallow, and that clearly reflects the sensitivity to price. We see significant changes in demand for the elastic good at the varying price levels. So now let's take a look at the three factors that have an impact on elasticity.
The three examples that we've just looked at give us insight to the three factors that affect elasticity or sensitivity. Here's the first: the availability of substitutes. For example, going back to the gasoline example, there's really no substitute for gasoline in our society. You'll pretty much buy it at whatever price it's set at. Needs versus wants. And gasoline provides us with a very good example here as well. Gasoline is certainly a need. It's not a want, so therefore it's inelastic and we'll buy what we need when we need it. The other side of that coin is we go down to the last example we looked at, which was the corn. Corn is certainly a want, not a need. There are other things that we can use as food, so therefore it is highly subject to price changes. The third factor that affects the sensitivity of a product or service is the proportion of income spent by an individual or collectively by the society. I'll go back to the gasoline example. I had mentioned that at some point of a price increase, you're not going to be able to afford to buy gas anymore, and you're going to look for other modes of transportation. So the proportion of the income that you have that's taken up by the purchase of the product will have an effect on things as well. Let's now look at two elasticity calculation examples. And I'm going to start us off with a real easy one first, just so we can illustrate the point about how this works. So, here we have an increase in the price of gasoline from $2.20 to $3 per gallon. And that results in a 1% decrease in sales. What we want to do is to figure out whether this product is elastic or inelastic at these price levels, and or more specifically, not only at this price level, but at this price level and price change level. Now, I say easy example because you already know, and we've illustrated the point, that gasoline is inelastic from a price sensitivity standpoint. So we know that, but what we want to do is prove it mathematically. The answer to this question, and let me give you the answer first, and then show you how you go about getting it. The answer is that in using our formula to figure out elasticity, it comes out to the following figure, 0.0275, and if you remember the measurement of it being less than 1, and 0.0275 is certainly less than 1, then we label a product being at that price level and price change level as being inelastic. Okay, so how do we get to these 0.0275? Well, if we go back to our formula, you may remember that in the numerator, in our division example here, we have the percent change in demand. And I actually gave you in this example, without having to calculate, what that percent change in demand is. Remember, demand is consumption, therefore consumption is sales. And we had a resulting 1% decrease in sales. So we put the 0.01 in the numerator. Now, in the denominator of the equation, we have the percent change in price. So going back to what we have, we see our change in price is 80 cents from $2.20 up to $3. To figure out the percent change in price, we need to take that 80 cents and divide it by the original number because we have an increase. So in other words, what percent is 80 cents of 220? And we find out that it's 36.3%. So we have 0.363 in our denominator. Now we're ready to solve our problem, or our formula, if you will. We take the 0.363 and divide it into the 0.01, and if you have a calculator available to you, you'll find that that will come out to the 0.0275, that being less than 1. Therefore, gasoline at this price level and this price change level is an inelastic product. Here's the second example, and this one is a little bit more involved. And what I mean by that is we have to do a little bit more work to get to our answer. The price of a haircut increases to $7.84 from $7. And this results in a decrease in sales, remember sales is consumption, from 40 to 27 haircuts per day. So what we want to do is to find out whether haircuts at this price level and price change are either elastic or inelastic, and prove it mathematically. Let me give you once again the answer to our question, and then show you how to get to the answer. In this case, the answer is 2.70, and because our answer is greater than 1, we therefore can classify this product at this price level and price change as being sensitive or elastic to the price change. Now, how do we go about getting to the 2.70? Well, we go back to our formula. And where I said a moment ago that this is a little bit more involved, I didn't give you one of the figures that you can plug into the formula in this case. In this case, we have to do our calculations both in the numerator and the denominator of our fraction. So let's start at the top and consider the demand aspects of things. Remember, at the top, we're looking for the percent change in demand. So the demand, meaning the sales or consumption, the change here was from 40 to 27. We had a decrease of 13. But that isn't good enough for us. We need to find out what percentage decrease in demand this is. So we need to take the 13 and divide it by the original number to figure out what the percentage of the original number, the percentage change was. And in this case, in dividing 40 into 13, we see that our solution is 0.325. Now let's go figure out the percent change in pricing, which is the denominator in your equation. We had a price change from $7 up to $7.84. This is an 84-cent change in the price of a haircut. But again, we want to figure out the percent change in price. So we need to take the 84 cents and divide it by the original figure, which is the $7, and we see that it's a 12% change, a 0.12. Now we're ready to solve for our elasticity question. We divide 0.12 into the 0.325, and if you have a calculator available, you'll see that it'll come out to 2.70. And again, that's greater than 1, so this product at this, excuse me, I shouldn't say product, this service at this price level and price change would be labeled or classified as elastic. I recommend to students that they go to the class website and view 2 supplemental videos that exist there. done by my friend Dr. Holden, who's great at explaining things. He has two videos there, part 1 and part 2, on the price elasticity of demand. It'll help put some additional depth behind the discussions we've had here over elasticity and demand. Up to this point, we have been looking at the first of 6 factors that could change demand in a market for a product or service. And that first factor has been price. And we know that when there's a price change, the way it has an impact on demand is that it affects quantity demanded, not total demand in a market. And that's clearly illustrated here in the example of our classic supply and demand graph. As you can see with our demand curve, that when we have a price change, we're affecting the actual quantity that's projected to be consumed. The example here being, if we switch from a price of 5 to 4, we'll see that there will be an increase in the actual total number of whatever the product is that winds up getting consumed. Now we're going to switch gears and we're going to take a look at the other 5 factors that will have an effect on demand. But what they will have an effect on is total demand in a market. And we're going to go back here to our classic supply and demand graph to start to help us illustrate these other 5 factors. Now you may recall that we used this with the example of a market for markers in Yuma that was based upon Yuma having a population of 100 people. So let's make sure we understand what we're looking at in our graph, is that with a population of 100, we were expecting that at a price point of 5, we would sell 10 markers, and at a price point of 1, we would sell somewhere between 50 and 60 markers. So what would happen when things are not held equal and some other factor affects the market? For an example, let's say the population of Yuma changed from 100 to 200. And I've used a simple illustration here of doubling the population. What kind of an effect would that potentially have? Well, what we have with this is a situation where we now have more opportunity. So stop and think about this for a second. If based upon a population of 100 at a price point of 5, we expected to be able to sell 10 boxes of markers, would it not be rational or logical, generally, to assume that if we had double the opportunity, even at the same price point of 5, that we could double the quantity demanded? Okay? Here we have a change in total demand from 100 to 200 in the population. And this is what we call an increase in total demand. And when we have a situation like this example, we need to change the graph and change specifically the demand curve on the graph to reflect this. It would look something like this. And if we go to the price point of 5, I think we've clearly illustrated that. The first price point at 5, where we were going to sell the 10 boxes, represented the population of 100. But it would be rational and logical to assume that if we have double the population, at the same price point, we could expect to double the quantity. Now, as you saw with the illustration I just gave you, an increase in total demand in a market shifts the curve on our graph to the right. We had a doubling of the population, therefore a increase in the total potential demand for the product or service, and we reflected that with a move or a shift of the curve to the right. If we had had a decrease in the population in the example I just gave you, where the population instead went down to 50 from 100, we would reflect that change in total demand by shifting the curve to the left. Now, there are other things that will shift the curves on our graph. We'll get into those here in a moment, but I want to spend a second or two reviewing what we've just covered here to make sure that you have a thorough understanding of the concepts involved. So to reinforce our concepts here, we'll go back to our more food for thought type situation, and we'll pose a question to you. And here goes. What is the difference between a change in quantity demanded and a change in total demand? Two things. First, a change in quantity demanded results from the change in price. And we see that clearly, that's clearly illustrated by movement along our demand curve. A change in total demand results from the other 5 factors that we're going to talk about, one of which I used in my illustration a moment ago, which could be a population change. So let me give you one other food for thought type question, and here it is. So what is the difference between a shift along a demand curve and a shift of the actual curve on the chart? The answer to that is, boy, that's the same question restated using different words, and that's correct. A shift along the demand curve reflects price changes. A shift of the curve reflects the impact of the 5 other factors of which we're going to talk about now. So here's the first of the other 5 factors that will affect a change in a demand for a product or service in a market. In the study of economics, we call it the substitution effect. And the substitution effect states that when a price of a good or service increases, consumers are more likely to buy an alternative as a substitute if an alternative is available. This is particularly true for products that are elastic. And please note here that in shifting our curves, it shifts the curve of the substitute product. Not the original product, but the substitute product. And this law can also be applied when a drop in price occurs. So let's take a look at an example. In our example earlier of using an elastic product, we used corn. Let's do something a little bit different here and use orange juice. Let's say in this example, for the substitution effect, we have the price of orange juice increases. Now, why would the price increase? We'll talk more about that in chapters 6 and 7, but let's just assume for the moment the price does increase. There are lots of other substitutes for orange juice. Let me suggest one as an example. Could be apple juice. And what happens when you have a price increase is that consumers in the portion of the market for orange juice will actually leave the orange juice market not wanting to pay the higher price and move to the apple juice market, which has a similar effect to increasing population, but it's been the result of a price change associated with a price change, in this case in the original market, to increase the demand, the total demand. Notice I said total demand of the apple juice market. The next thing that can have an effect in changing total demand for a product or service within a market is what we call in the study of economics the consumer income effect. It's when consumers can no longer afford to buy the same combination of goods and services because of a price change. And this effect, like the substitution effect, also works in reverse. To have a deeper understanding of the consumer income effect, we need to give you some definitions with regard to yet some other ways that we classify products and services, or goods and services, within markets. So let's do that now. There's a thing that we call a normal good, and these are goods that consumers will demand more of when their incomes increase. Another category of type of product or service is called inferior goods, and these are goods that demand will fall for when there is an increase in consumers' income. To illustrate how this works, I'm going to use the automotive industry, and I'm going to take two products, BMW and Hyundai, broadly. Now, naturally, they have lots of products within their product line, but here's the point. Each one of these brands are known for a certain profile, if you will. BMW, high performance, relatively expensive cars. Hyundai, lower performance, generally cars, budget oriented but very efficient, targeted at a broader market of people that need transportation. When incomes increase, we can expect to see an affected change in total demand market for BMWs to increase, which would shift the demand curve for BMWs to the right. At the same time, with consumers' incomes increasing, they will opt for the BMW at the sacrifice of the Hyundai product line, and therefore we should expect to see a decrease in the number of Hyundai products sold, or a shift in demand of the Hyundai demand curve to the left when their incomes increase. Another category of type of product or service is called inferior goods, and these are goods that demand will fall for when there is an increase in consumers' income. To illustrate how this works, I'm going to use the automotive industry, and I'm going to take two products, BMW and Hyundai, broadly. Now, naturally, they have lots of products within their product line, but here's the point. Each one of these brands are known for a certain profile, if you will. BMW, high performance, relatively expensive cars. Hyundai, lower performance, generally cars, budget oriented but very efficient, targeted at a broader market of people that need transportation. When incomes increase, we can expect to see an affected change in total demand market for BMWs to increase, which would shift the demand curve for BMWs to the right. At the same time, with consumers' incomes increasing, they will opt for the BMW at the sacrifice of the Hyundai product line, and therefore we should expect to see a decrease in the number of Hyundai products sold, or a shift in demand of the Hyundai demand curve to the left. Our next point to consider is consumer expectations. And changes in consumer expectations can have dramatic effects in changing total demand within markets. Now let me use an example, a simple example. A number of years ago, here in the United States, we had an E. coli breakout in a very small portion of the spinach market, in where a couple of people were poisoned as a result of the spinach contamination, and it led to an industry-wide panic which had dramatic effects of reducing the total demand for spinach in a market. And the E. coli contamination was found in a very narrow area, but the expectations were widespread that the entire spinach crop was contaminated and it had a devastating effect on the spinach business. But here's a question for you to show you the power of consumer expectations, not only in a singular market like this example with spinach, but also can spread to others. What would you have expected to have happened based upon the E. coli scare and the contamination scare in the spinach market to the lettuce market? Some people naturally wind up saying that they would expect the substitution effect to kick in, and people who may have bought spinach before would move to lettuce, which didn't show any contamination, and they would expect the lettuce market demand curve to shift to the right to show an increase. Well, actually what happened was there was a significant reduction or decrease in total demand in the lettuce market as well, and that's because the consumer expectation spread so far to the point that people considered anything that was green and leafy to be potentially contaminated, and that wasn't good for the lettuce business as well. Two other items that could have a dramatic effect on total demand in the market. One we saw in our initial example, population size, pure and simple. If you add more people into a market by sheer numbers of the population just growing, that can affect the change. And also, advertising can change consumer preferences and change total demand within a market as well. Total demand shifts within markets can have two major effects. First is that consumption of complementary and substitute goods and services can be dramatically affected. We saw this with our examples of the orange juice and apple juice markets, and also the spinach and the lettuce example. But I want to give you one more example and use a complementary set of goods to further illustrate this point. Let's say we have the market for peanuts, and something happens to the peanut market that winds up having an effect on total demand of reducing total demand in the market for peanuts, which moves its demand curve to the left. A complementary product for peanuts, if you're a fan of peanut butter and jelly or peanut butter and jam sandwiches, is the jam market. Distant but related. Okay? What would be the effect of a reduction in the peanut market to the jam market? I think you can see where I'm going in this. We would have a reduction in the jam market as well, with its demand curve shifting to the left. The second major effect of total demand shifts in a market would be potentially that shortages may occur. If you can think back to the example of the apple juice and orange juice market, when people shifted from orange juice to apple juice, the producers of apple juice may not have been anticipating what happened in the orange juice market and may not have been able to supply stores with enough apple juice to make up the difference or the increase in demand. What happens in those cases is that there's a run on the other product, meaning the apple juice, and apple juice disappears from the shelves in the stores a lot quicker, and before the store owners can restock shelves, in many cases you wind up running into shortage situations that occur in the market. As we move towards closing Chapter 5 here, I want to make a few comments about the proper labeling of graphs. In our study, you're going to be drawing and illustrating using quite a few graphs throughout the year. And you need to be very fastidious, meaning pay a lot of attention to the clarity and accuracy of your graphs. And the reason for this is that our graphs are going to get far more complex than what we have looked at in this chapter. And you want to make it comfortable for the reader of your papers, whether it's your fellow students all the way up to the people reading and scoring the AP exams for you, for them to be able to understand what you're trying to illustrate. So before I go into a little bit further here to the actual proper labeling, I want to make another recommendation that when you are drawing your graphs, make sure that they are big enough, you got plenty of room, and that will help to be able to make them clear to the reader. Okay, a couple of things with regard to proper labeling. As I have shown you on every graph that I have done, there's been a title to the graph. Your reader will not know what you're talking about unless you properly title your graph. Also, before early on in this chapter, I had mentioned that the labels for our axes do not change at all. They always need to be labeled price and quantity. Our demand curves are labeled with the letter D, and remember, demand curves always slope downward from left to right. And you have noticed that when we have a change in total demand in market, we show the shift to either the right or the left to show either an increase or a decrease with an arrow and a broken line, and with the label D1, meaning our secondary level move of the demand curve. Now, I've used color here, and I'll continue to use color because it's easy on the eyes and helps to illustrate the concepts that I'm trying to get across to you. When you're writing your papers and also on the AP exam, you're not going to have the luxury of being able to color code your curves, which brings even more importance as to why you need to make sure your graphs are large enough so that they can be clear enough, and also that they are properly labeled so that people know what you're trying to illustrate. One other point here too, notice in each case through this chapter, I have used the words either a shift to the right for my curve or a shift to the left, meaning an increase or a decrease, and I have not used the words up or down. And as we go into the next two chapters, that will become abundantly clear as to why you should never use the words up and down to describe shifts of curves. I'll just leave it at that for the moment. All right, let's wrap up this chapter with two examples of some questions that you might be asked with regard to market condition changes and how we would illustrate that from a demand standpoint. Okay, here we have our classic supply and demand graph with our demand curve. Your market is cereal. We all like cereal. And here's the event that occurs in the market. The price of milk doubles. What will happen to the market for cereal? Well, milk is a product complement or complementary product, and we have a change in the price of milk. It doubles. What impact will that have on the market for cereal? There would be a shift in the demand curve, a decrease in the market for cereal. As a result of milk prices going up, people will not be able to afford to buy milk in the same volume, and therefore turn away from buying cereal because it's a complementary product. Let's try another. Again, we have our classic supply and demand graph, and in this case our market is bus tickets. The event that occurs is the price of airline tickets doubles. What happens to the market for bus tickets? Again, in this case we have a price increase, but it's in an increase in a related product substitute, not a complementary product. And we know what happens in that case. The market shifts for the substitute product. In this case, bus tickets. We should expect to see an increase in demand for bus tickets. And we shift our curve to the right. That wraps it up for Chapter 5. In Chapter 6, which is all about supply, we shift our focus here and take our classic supply and demand curve a little bit further, and I'll look forward to seeing you in Chapter 6.